Magnetic resonance imaging is an imaging technique used in medical settings to produce high quality of the inside of the human body. The MRI scanner consists of a 24-inch tube, inside which the examination takes place. It is made up of 4 components. The magnet is the most important part and the biggest component of the whole scanner. The magnet is rated using a unit known as Tesla or Gauss. 1 Tesla equals 10,000 Gauss. The range of the magnetic field of an MRI range between 0.5 to 3 Tesla or 5,000 to 30,000 Gauss. A gradient coil is an independently energized coil that creates a linear gradient in a relatively homogeneous magnetic field. There are 3 different gradient coils, located within the main magnet. Each one of these produce 3 different magnetic fields, creating a variable field, X, Y, Z, that can be increased or decreased to allow specific and different parts of the body to be scanned by altering and adjusting the main magnetic field. X coil creates varying magnetic field from left to right across scanning tube. Y coil creates varying magnetic field from top to bottom across scanning tube. Z coil creates varying magnetic field from head to toe. The function of radio frequency coil is to transmit radio frequency waves into the patient body. RF coils create the B1 field which rotates the net magnetization in a pulse sequence. RF can be divided into 3 general categories. 1. Transmit and receive. 2. Receive-only coils. 3. Transmit-only coils. All the controls of the scanner are handled by a computer. The human body is mostly water. The water in our body is found in 2 main locations, in our cells and outside our cells. The atomic structure of water includes 2 hydrogen atoms and 1 oxygen atom. And it is the hydrogen nuclei or proton that are important in MRI scanner. At any moment in time, all hydrogen protons in our bodies are all in random positions and spinning on their axes. When the human body is placed inside an MRI scanner, a strong and uniform magnetic field B0 is applied. This strong magnetic field aligns all the protons in human body. Some protons align up, parallel, and some will align down, anti-parallel, while still spinning around on their own axes. The B0 field not only affects the hydrogen protons' alignment, but also affects how fast these protons spin, called as Larmor frequency or precessional frequency. The precessional frequency depends on the strength of the magnetic field and is calculated from the Larmor equation. When an radio frequency pulse with the same frequency as the proton's precessional frequency is turned on, the up protons flip away from the B0 field, as they absorb the RF energy. When the radio frequency pulse is turned off, the protons flip back and realign along the main magnetic field, B0. As the protons flip back and realign with B0, they give off energy. Different tissues in the body give off different amounts of energy. To measure this emitted energy, a radio frequency receiver is placed inside the body of the MRI and detects the released energy as an electrical current. The electrical current is transformed, via a computer, using a mathematical calculation called Fourier transformation. A Fourier transformation is a mathematical calculation that is used to change the electrical current into an image. It converts a signal into individual spectral components and thereby provides frequency information about the signal. Magnetic resonance imaging, MRI, is a non-invasive way to view organs and does not use radiation. Gives extremely clear detailed images of soft tissue structures. But on the other hand, MRI examinations are long because it is needed to acquire sufficient data to build a complete image.